We've reached the end of another skill, so let's review what we've learned by taking a quiz. First up out of 4 questions. What mechanism is used by the fabric interconnects for sending traffic upstream? The answer here is C, pinning. We are going to see that the fabric interconnects are running in what we call end-host mode. End-host mode tells it that it can learn MAC addresses downstream, but it cannot learn them upstream. As a result, when traffic arrives from a downstream interface and it's destined for upstream, well, the way we know it's destined for upstream is that we don't know where the MAC address destination lives. Because we're not learning them upstream, we assume that an unknown unicast is destined for an upstream interface. At that point, we could have many upstream interfaces. In order for these all to be in an active state, we simply use pinning. We say that if it arrives on this particular virtual Ethernet interface, we get pinned to here. Or if it arrives on this virtual Ethernet interface, it pins to here. So pinning is done on a VNIC basis, in other words, a virtual Ethernet interface, which is why, again, pinning C, that is our answer. Second question, which part of the incoming Ethernet frame is observed during the deja vu check? The answer here is A, the source. Remember, we have 2 different checks. We have the deja vu check, which checks the source, and then we have the RPF check, and the RPF check is checking the destination. When we're looking at a fabric interconnect, we want to make sure that if we're receiving a packet on one link, that it's not a packet that we already sent out via a different link. This is especially useful from a broadcast perspective because we can expect if we send a broadcast upstream that the switch is going to do its job. It's going to bring it in on the one interface, it's going to send it out the other interface. Which means that every broadcast we send, we should expect a duplicate to arrive on any other active interface in that VLAN. And so the deja vu check is going to check the source to say, hey, did I actually already process that? In other words, did it come from a host that is downstream of me? And so we do want to keep this straight in our minds that the deja vu check is all about checking the source destination for this situation, and the RPF check is going to check the destination and make sure that it's arriving on the correct interface. Question 3. Where are the VETH ports located in a UCS architecture? The answer is B, fabric interconnects. Remember, in a UCS architecture, we have all of these components. We have a Nexus switch upstream, or maybe it's not a Nexus switch. Maybe it's not even a Cisco switch. That part's irrelevant. But then we connect down to the fabric interconnects. The fabric interconnects are going to connect through an I/O module if it's a blade chassis. It might be a FEX if it's a rack mount server. And then in the end, we have the VIC. And so any one of these components could believably be where we're going to terminate a virtual Ethernet interface. However, it's important that we recognize that it happens on the fabric interconnect. The VETH port is going to tie down into the virtual space to a particular VNIC. We spin up these VNICs inside of the UCS manager configuration, and it's presented to the host downstream as if it's a physical connection. Last question, how many VETH ports are created for a VNIC configured for failover? All right, so the answer here is 2, but let's walk through this scenario. What we have is we have a VIC, and that VIC is going to connect up to 2 different fabric interconnects. Sometimes directly, sometimes via an I/O module or via FEX. But either way, when we spin up a VNIC, this VNIC is bound to a single fabric at a time. And so by default, if we just configure this to connect through fabric A, the VNIC is going to form a VETH port on fabric interconnect A. However, if we configure this for failover, well then we need a path through the other fabric. And so we're going to configure a VETH port on the fabric interconnect B. However, this is in a suspended state. We're not actually going to use this unless our path through fabric interconnect A were to go down. And by the way, that could be that the fabric interconnect itself dies, it could be that its uplink upstream dies and we don't have another interface to pin to, or maybe even the I/O module in the middle goes down. Any one of these failures would result in the VIC recognizing that, hey, I don't have a path out anymore, and so I'm going to swing that connection over to fabric interconnect B. So because we're creating a virtual Ethernet interface on both fabric interconnects, that would result in 2 being created in a failover scenario. And that wraps up this quiz. If you found that your knowledge banks didn't quite fail over appropriately, I don't know if that analogy works, but either way, be sure to go back and watch the appropriate videos in order to complete any missing knowledge. Otherwise, congratulations on completing Explain UCS Networking. I hope this has been informative for you, and I'd like to thank you for viewing.